In 1955, a physicist sat down to write a letter of condolence, and what he wrote in that letter has been quietly unsettling people ever since. His closest friend of over 50 years had just died, and instead of the usual words of comfort, he wrote something that sounded less like grief and more like physics. He told the grieving family that people who understand the universe, the way he did know that the line we draw between past, present, and future is only a stubbornly persistent illusion. That physicist was Albert Einstein, and within a few weeks, he himself would be gone too. So today we are going to sit inside that letter, unpack what it actually means, and walk through what relativity, the real tested, working theory of physics, actually says about time, about the people we have lost, and about whether death is the ending we have always assumed it to be. Before we go further, if this is the kind of question that keeps you up at night, the kind of question that sits underneath religion, philosophy, and physics all at once, this is exactly the territory smart psychology was built to explore. So if that sounds like your kind of thinking, sticking around and subscribing means you will not miss where this goes next. Let us start with the part almost everyone gets wrong without realizing it, which is what time actually is according to physics. In everyday life, we treat time like a river. There is a past behind us that is gone and fixed. There is a present moment that is the only thing that truly exists right now. And there is a future ahead of us that has not happened yet and is still open, still undecided. This feels obvious. It feels like the most basic fact of existence there is. But when Einstein published special relativity in 1905, and later general relativity in 1915, he was not describing a small correction to this picture. He was quietly demolishing it. Here is the core discovery, stated as simply as it can be stated. There is no universal, agreed-upon present moment that everyone in the universe shares. Two observers moving at different speeds, or sitting in different gravitational fields, will disagree about which events are happening at the same time. This is not a measurement error, and it is not a limitation of our instruments. It is a fact about the actual structure of reality. Physicists call this the relativity of simultaneity, and it has been confirmed experimentally over and over again. From particle accelerators to atomic clocks flown on airplanes, to the GPS satellites orbiting above your head right now, which have to correct for this effect constantly, or your phone's map would drift off by miles within a single day. Now, why does this matter for death? Follow the logic carefully, because this is where things get strange. If there is no single universal now, then the idea of the past being gone and the future being not yet real starts to fall apart. A mathematician named Hermann Minkowski, who had actually taught Einstein years earlier, took Einstein's equations in 1908 and showed that space and time are not two separate things at all. They are one single four-dimensional structure, which we now call spacetime. In this structure, every event that has ever happened, and every event that will ever happen, exists as a fixed point, a coordinate. Your birth is a point in spacetime. This video is a point in spacetime. The death of anyone you have ever loved is a point in spacetime. None of these points are more or less real than any other. They simply sit at different coordinates. The way New York and Tokyo both exist, even though you are only standing in one of them right now. Physicists have a name for this view. They call it the block universe, sometimes eternalism. Under this framework, the universe is not something that is being created moment by moment as time ticks forward. It is a complete, four-dimensional block that already contains everything, past, present, and future, all at once. The way a DVD already contains every scene of a movie even before you press play. Your sense of time flowing, of moving from one moment to the next, is real as an experience, but according to this view, it is something your consciousness does, not something the universe itself is doing. The universe does not flow, you flow through it, or more precisely, your awareness moves along a fixed path that already exists in full. This is not a fringe idea dreamed up by mystics. It comes directly out of the mathematics of general relativity, and it is taken seriously by a large number of working physicists. Kurt Gödel, one of the greatest logicians of the 20th century, and a close friend of Einstein's at Princeton, worked out solutions to Einstein's equations that seemed to allow for closed time-like curves, and he used this as an argument that the flow of time must be, in his words, a mere illusion. Physicist Brian Greene has spent much of his public career explaining this exact idea to general audiences, describing space-time as something more like a loaf of bread, where every slice, every moment, is baked in and permanent, none of them disappearing once we move past them. They are simply not the slice we happen to be looking at anymore. So let us go back to Einstein's letter, because now the words hit differently. When he told the family of his friend, Michele Besso, that the distinction between past, present, and future is only a stubbornly persistent illusion, he was not offering poetic comfort. He was stating, as literally as he knew how, what his own equations told him about reality. Besso had not stopped existing in any absolute sense. Under this view, he simply exists at a set of space-time coordinates that your consciousness, moving forward the way it does, no longer has access to. The moment of his life is still there, the way your 5th birthday is still there, fixed permanently in the structure of the universe, even though you cannot walk back into it. It also helps to understand where this feeling of flowing time comes from in the first place, because if the universe itself is static and complete, something has to explain why we experience it as a story unfolding, rather than a picture already finished. Physicists point to something called entropy, which is a measure of disorder, as the likely source of our felt sense of direction in time. The universe began, as far as we can tell, in an extraordinarily ordered, low entropy state at the moment of the Big Bang, and it has been getting more disordered ever since. Coffee cools, ice melts, rooms get messier on their own far more often than they spontaneously get tidy. This steady increase in disorder gives us what physicists call the arrow of time, and many researchers believe our memory itself is built on top of this arrow. We can only form memories of the lower entropy direction, which we call the past, and never the higher entropy direction, which we call the future. In other words, the flowing, forward-moving feeling of time may not be a property of the universe at all. It may be a property of brains like yours, built out of the thermodynamics of the universe, reading a fixed structure in one direction, the way your eyes read a sentence from left to right, even though every word on the page already exists at once. This is a genuinely strange thing to sit with, and I want to pause here and be honest with you about something, because this channel is not in the business of telling you comforting stories dressed up as science. This idea is real physics. It comes from a Nobel Prize-winning theory that has been tested more precisely than almost any other idea in the history of science. But it is also genuinely debated, and I am going to walk you through both sides fairly, because you deserve the whole picture, not just the part that feels good. There is a real philosophical fight going on here, and it has been going on for over a century. On one side, you have eternalists, sometimes called block universe theorists, who take relativity at face value and say all moments are equally real, full stop. On the other side, you have presentists, who argue that only the present moment truly exists, and that the past is gone and the future has not yet been created, whatever the mathematics of relativity might suggest. Philosopher William Lane Craig has argued extensively that presentism can be reconciled with relativity if you interpret the theory in a particular way, treating simultaneity as a matter of convention rather than a deep metaphysical fact. There is also a middle position called the growing block theory, associated with philosophers like C.D. Broad, which says the past and present are real and fixed, but the future genuinely does not exist yet. It is still being added, moment by moment, like new pages being written onto the end of a book that already has a beginning and a middle. I am telling you about these competing views because intellectual honesty matters more to me than a tidy ending, and because I think you are capable of holding complexity, which honestly most content on this topic does not give you enough credit for. Before we go further, this is exactly the kind of question worth sitting with rather than scrolling past. So if you want more of this, dropping a comment with your own take, even if it is disagreement, genuinely helps this reach more people who are asking the same questions you are, and it helps me know what to dig into next. Let us talk about what this actually means for how we experience grief and loss, because this is where the physics stops being abstract and starts touching something personal. When you lose someone, the pain comes largely from the sense of absolute severance, the feeling that they have gone from existing to not existing, that the door has closed completely and permanently. Under the block universe view, that specific framing is not accurate. Every conversation you had with them, every ordinary Tuesday afternoon, every moment where they were fully alive and fully present, those moments are not destroyed. They do not get deleted from the universe the moment a heart stops beating. They remain exactly as real as they always were, permanently fixed in spacetime, the way the moment of your own birth remains real, even though you have moved far past it. What has changed is only your position relative to those moments, not the existence of the moments themselves. Think about a specific afternoon you spent with someone who is now gone, the sound of their voice in an ordinary kitchen, a joke that made both of you laugh far too hard, an argument that got resolved by evening. Under a purely presentist view, that afternoon is simply gone, erased, existing now only as a fading pattern of neurons in your own head, and once you forget the details, or once you yourself are gone, it stops existing anywhere at all. Under the block universe view, that afternoon never stops existing. It is permanently there, at its own fixed coordinate in space-time, as real and as solid as the chair you are sitting in right now, and the only thing separating you from it is the same kind of distance that separates you from a city you are not currently standing in, not an absence, just a different location within a structure that holds all of it at once. Physicist Sean Carroll, who has written extensively about time and the arrow of time, points out that this does not mean death does not matter, or that loss is not real. It very much is. The connection you had access to in the flow of your own experience has genuinely ended for you, but it reframes what exactly has ended. It is not that the person and every moment of their existence has been erased from reality. It is that your particular thread of experience, moving forward through spacetime the way it does, has separated from theirs. The relationship, as a set of real events, is not undone. It happened, and having happened under this view, it can never come undone. Nothing in physics can go back and erase a moment. Once it exists in the structure of space-time, that is actually one of the more startling implications of the theory. Permanence is built into the fabric of it. It is worth saying, too, that this is not the first time a serious thinker has landed near this idea, long before Einstein ever picked up a pen. The philosopher Parmenides, writing in ancient Greece, argued that change and becoming were themselves illusions layered on top of a deeper, unchanging reality. And centuries later, the philosopher Boethius, writing while awaiting his own execution, described eternity not as endless time, but as the complete and simultaneous possession of all of existence at once, a description that lines up almost eerily well with what a modern physicist means by the block universe. None of this means ancient philosophy predicted general relativity. That would be overstating it badly, but it does suggest that human beings, independently, from completely different starting points, keep bumping into the same strange intuition that the wall we imagine between what has happened and what still exists may be thinner than it feels. There is also a very grounded, testable piece of relativity that backs this up, which most people never learn about outside of a physics classroom. Time itself passes at different rates for different observers, depending on their speed and the gravity they experience, a phenomenon called time dilation. Astronauts on the International Space Station actually age very slightly slower than people on Earth because of their velocity, and this has been measured directly with atomic clocks. The astronauts return home younger by a tiny but real fraction of a second, compared to if they had stayed on the ground. GPS satellites experience time faster than clocks on Earth's surface because they sit in weaker gravity, and the correction for this is built into the system's software. Without it, GPS coordinates would be wrong by several miles within a single day. This proves, beyond any reasonable doubt, that time is not the fixed, universal ticking clock our intuition assumes it to be. It is flexible, relative, and tied to the physical structure of space-time itself, exactly the kind of structure that makes the block universe interpretation something worth taking seriously rather than dismissing as a comforting metaphor. There is an even more dramatic version of this effect, involving tiny particles called muons, which are created when cosmic rays strike the upper atmosphere. Muons decay so quickly, in a few millionths of a second, that under old non-relativistic assumptions, almost none of them should ever reach the surface of the Earth before falling apart. Yet we detect them at ground level in enormous numbers, and the reason is time dilation. From our frame of reference, the muons are moving so close to the speed of light that their internal clocks run dramatically slower, giving them just enough extra time, by our measurement, to complete the trip. This experiment has been repeated in laboratories and observed in nature so many times that it functions almost as a routine demonstration in university physics courses, and it is a small, humbling reminder that the strange, sliding, relative nature of time is not theoretical. It is happening above your head at this very moment. Now, I want to be fair to the strongest objection to all of this, because I promised you the full picture. Quantum mechanics, the other great pillar of modern physics alongside relativity, does not sit comfortably with a fully fixed, unchanging block universe. In quantum theory, there is a genuine role for randomness and for events that appear to be undetermined until they are measured or observed. Physicists have spent decades trying to reconcile the deterministic, block-like picture from relativity with the probabilistic, seemingly open picture from quantum mechanics. And there is no fully agreed-upon resolution yet. This is one of the biggest open problems in all of physics, sometimes called the search for a theory of quantum gravity. So when someone tells you with total confidence that physics has proven your loved one is somehow still there in an eternal unchanging block, they are overstating the case. The honest answer is that relativity strongly points in that direction, while quantum mechanics complicates the picture, and physicists are still working out exactly how these two descriptions of reality fit together. What I find remarkable is not that physics has solved the problem of death. It has not, and I do not want to oversell this to you. What I find remarkable is that one of the most rigorously tested theories in the history of science, a theory behind the device in your pocket right now, quietly implies that our everyday intuitive picture of time, the river flowing from a real past through a real present into an undetermined future, might be the illusion, not the other way around. That is a genuinely radical thought, and it did not come from a philosopher trying to comfort people. It came from equations that predict the orbit of Mercury and the bending of starlight around the sun with extraordinary precision. If this kind of thinking is changing how you see something in your own life, that reaction is worth paying attention to, and it is also exactly why a community built around ideas like this one matters. So if you have not already, staying subscribed to Smart Psychology means these deeper dives keep showing up for you instead of getting lost in the noise. It is also worth noting that this framework does not require anything supernatural to make sense, which is part of why so many physicists, including ones who describe themselves as non-religious, take it seriously rather than dismissing it outright. There is no soul required in this picture, no separate spiritual realm floating outside the physical universe. The claim is much narrower and much stranger than that. The claim is simply that spacetime itself, the same physical structure that bends light around the sun and slows clocks on satellites, already contains every moment as a permanent feature of its geometry. That is a claim about physics, not about an afterlife in the traditional religious sense. And part of what makes it so compelling to so many serious thinkers is exactly that it does not ask you to believe in anything beyond what the equations themselves already describe. So where does this leave us? It leaves us with a genuinely open, genuinely serious scientific and philosophical debate, not a settled answer, but an important one to know exists. The equations of general relativity, taken at face value, suggest that every moment of every life that has ever been lived remains permanently woven into the structure of the universe, not gone, not deleted, simply not accessible to your particular thread of experience anymore. Einstein believed this deeply enough to write it, almost as a matter of scientific fact, in a letter meant to comfort a grieving family, days before his own death. Whether you find that comforting, unsettling, or simply fascinating probably depends less on the physics itself and more on what you bring to it. But either way, it is worth knowing that this is not New Age speculation borrowed loosely from science. It is a real, live, ongoing conversation among some of the most serious minds in physics and philosophy, and it suggests that the hard line we draw between being and not being might be far less solid than it feels from inside a single moving moment of time. The next time you think about someone you have lost, or honestly the next time you think about your own mortality, it might be worth remembering that according to the deepest physical theory we have ever built, nothing that truly happened has ever actually stopped happening. It is simply, from where you are standing right now, a little further down the road than you can currently see. If this shifted anything in how you think about time or loss, that is exactly the kind of conversation worth continuing. So share this with someone who needs to hear it. Leave a comment with the part that stuck with you the most, and subscribe to Smart Psychology so the next video that reframes something you thought you understood lands right in front of you.